Hello, welcome to my bench. I'm sorry I haven't been around much. I haven't made any videos for over a month because I've been sick. I don't know what that cold or flu or whatever it was that was going around was, but it took me out, and it's been well over 3 weeks. So, you know, that's I didn't feel like doing much of anything. So anyway, here we are, and today on the bench we have something old, and I mean old. This little piece of equipment is primarily for radio stations, and it was made around 1969. I remember back in the early 80s using this little guy out on remotes with Billy Weber, and it worked just fine then, and believe it or not, the silly thing still works to this day, more or less. This thing is in need of some serious cleaning, but other than that, most of it works. One channel does not, and we'll get into that later. What this is a Sparta RA-5 Radio Amplifier 5. If we can get a look down here at this, yeah, right there it is. And this particular one is serial number 210. Can we get, yeah, there it is, 210. I don't think they made very many of these guys. I've never seen one other than the 2 or 3 that we have at my radio station. And it's Sparta it was a pretty big name for a while. We have a couple of Sparta control boards for studio boards that are kind of interesting, and maybe if I can get a hold of one of those, we'll tear it apart and look at it. But they take up the whole bench. They're huge. You'll have to make some other way of doing this. But what this is a microphone amplifier, dual mic amps, plus, if we look back here, plus it also has a line out, which is right here, and a PA out, which is basically just line out but a different connector. We'll see that. And a channel 2. You got channel 2A and channel 2B. If it's on B, it's a microphone input. If it's on A, it's an external input that you can control. So you have some say some other source coming into you from, I don't know, a soundboard or something that somebody's got out on a remote. You can plug it into this thing and switch it over on the front here to A, and you get that input that you can control in this meter here. Or 2B, which is another mic input if you want to do interviews or something like that. We can also see down in the back here, it's got internal and external. That's for power. This thing will hold 9-volt batteries, and you can power it on the 9-volt batteries for a fair amount of time. Not tremendous, but you know, it'll work through a couple-hour remote. But you also have power input here. It's not we'll get into that power thing here in a minute. Then it has a high and low level input for this input here. So if you've got a low level input, you'd be using mic level. High level input, you'd be using something external like a line amplifier. And it's got these outputs that would go to like your Marty remote transmitter or something like that, and these are line level. As you can see, the box is rather interesting. The whole thing is, there's no screws on this side, as you can see. Let's get this back out a little bit. There's no screws on the sides holding it in. The screws are a couple here, one there, which is missing. 3 of them up here, 1 of them here, and there's supposed to be 4 on the bottom. 2 of those are missing, and this is the battery compartment. So let's open this up. Whoops, wrong sized bit. Guess you gotta take this one all the way out. Even though there's a slide for it, you still have to take it all the way out. Oops. That was clever. Just threw a bunch of screws across the desk. Alright, this is where the batteries go. And as you can see, it holds 3 9-volt batteries for 18 volts. And it has a little fuse right here, which is the line fuse, so that it protects, well, I guess the transistors are in there to protect that valuable fuse. But it just, that's where your batteries go, and you can run it on batteries more or less. Let's put this back on, because things just sort of get in the way. Where's my pliers? This unit was sitting out in the transmitter building, this particular unit, for years. And it was used to communicate between the transmitter building and the other building that's like 265 feet away. It was just used as a mic amplifier. And it came with this. This is an Electro Voice model 654A, and it's 150 ohms. It is made in Buchanan, Michigan. Little microphone with a standard connector on the bottom. This guy's broke. The element's no good. They're pretty fair mics. Rugged. I mean, this thing is metal, all metal, and it's just, but the element's busted, so it's no good. We got another mic we'll test this with. Alright, so that's this little box for now. This is the power supply. This is a model PS3, and this one is serial number 152. Let's see if I can get that. Too much light, and it's shiny. Take my word for it. Made in Sacramento, California. And we're going to take a look at this first. We'll put this off to the side. And let's open up this little guy here. This was an option that you could buy for these, and it was pretty necessary if you're going to do anything for any length of time. Another screw missing. Isn't that wonderful? Alright, so here's what we got. A little power supply with a big old honking cord on the end of it, or plug on the end of the cord. The cord's in pretty good shape. It's original. It's old, but it's original. And the other end, this is the connector that goes into the back of the unit itself. And as you can tell, there's not a tremendous amount in this thing. Basically, it's got a transformer, filter cap. This is a bridge rectifier. That's a Zener down there. We'll take a look at the schematic for this. This is a dropping resistor for the neon light right there that comes on. And some sort of a resistor down there. But that's basically all that's in this thing, and a fuse. It's got a slow blow. I don't know what it takes. We'll find out. This particular fuse that's in here is a 1 amp. That seems a bit high, but we'll look at the schematic. Like everything else that Sparta made, this thing is just you know, built way down, sort of good and rugged and solid, but just good enough. Sparta wasn't what you'd call a fantastic product, but they were okay. We're going to leave the top off here because I want to show you something. I can plug this in, but it wouldn't do me any good, because in order for this power supply to work, it has to be plugged into the unit itself so that it senses the fact that the unit's there and turns the thing on. Alright, so much for that. Now, excuse me, let's go about getting into this. Like I said, everything's sort of a weird little building block of screws holding this thing together. And I haven't had one apart in a while, and I don't really remember how it works, so we'll start with the obvious. Let's take the bottom off first. And like I said, there's only a couple of screws here, because somebody somewhere in the annals of history has lost a couple of screws. So no, that didn't work. Well, maybe it's held on here, so let's take this one off the front. I guess that worked. Alright, so there's the insides. And of course this is fully fastened on here. Wow, okay. Well, here's what we got. In true radio fashion, all of the wires are numbered with little number tags on them. This is wire 10. What's this one? That's wire 11. Here's wire 4. Yeah, that's the way we do it in radio. Every wire's numbered so that you can trace it through. And these are actually still here. Down there's number 6 and number 5. And the wire numbering is still on there. That's pretty amazing. This is the board, the main board for it. As you can see, it's sort of a combination of point-to-point wiring and a little board. And the little board has... This is cute, boy. The old days, I swear. Alright, let's pull this in. See if we can get a good look at this, if I can focus there. Ooh, come on. There we go. You see these leads? Here, 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 here. All those leads sticking through the boards? Those are transistor leads. That's cute. This whole thing, if we take a look at the schematic, is PNP transistors. And when we measure voltages in here, they're all going to be negative. So this is cute. This is fun. And like I said, I haven't been to one of these in forever. I don't know if I want to take the sides of this thing off. Let's see what else is in here. There's a little transformer down there. Is that a transformer or is that an audio coil? It might be an audio coil. Probably is. Alright, well, I have to take the sides off because I got a screw here that goes through the board and it's captured on the other side. So I can't actually get the board out without taking the sides off. Alright, let's hold the sides in. Besides luck. Well, definitely this one down here. That one's for sure. That sort of made it wobble a little. So I guess this one up here. I do remember in the back of my mind that if you take too much apart, the whole thing just goes plop. So I don't really want to do that if I can get away with it, or from it. Alright, so that did that, but it didn't help because I still got this thing screwed onto there. There's a couple of screws back here. Actually, there's 3 screws back here. Are they holding the whole thing in, or is that down the... Wow, okay. Well, those have nuts on the other side, so taking those out isn't going to help me much. Okay, well, I guess I got to take it all the way, the rest of the way apart. Well, there's one side. And how about the back? Okay, I guess that's these guys up here. Alright. Yeah, okay. I was right. The whole thing just sort of comes apart and goes flop. I try to be careful here because of the wires are probably pretty brittle considering 1969. Alright, so let's get down in here and get this one that's holding the other side on and onto the motherboard, the little board that's in here. Alright, there's the other side. So far, so good. Alright. Let's take a look at what we got in here. Wow. For a little microphone amplifier, this thing is pretty complicated. Let's see. Get this in a good position so I can show it to you. I guess that'll do. Get some of the wires out of the way. Alright, here we go. What do we got? Alright, there's the board. These are electrolytics. All of these are electrolytic, plastic encased electrolytics. Those are interesting. Here's your transistors. Like I said, these are all, probably all PNPs, considering it's 1969. I'm not real sure the reason why PNPs were so popular in the early days, but probably that's the way that they're made. When they were made, that's how they turned out, and that's what they were using. I know they had NPNs, but I think PNPs were the standard. And they're germanium. I guarantee it. In that era, these would be germanium PNP transistors. And germanium PNP and noise basically is the same word. By today's standards, this thing is not very quiet. I love the way, if you can see, look at the, see if we can get in a little farther here. Come on. Focus. Focus. Nope, not going to focus that close. Alright. Look at the transistor, the resistors. Look at how the leads are bent on everything. They're up, over, and down. Instead of just kind of wrapping around and going there. And the capacitors here too. Ah! And it's got these little guys. Those generally never go bad. That orange drop there, it'll be fine. The resistors will be okay, I'm sure. And the transistors, we'll see on those. What do we got here? What are these? Alright, so we have, what is that, 50? Yeah, 50 microfarads at 25 volts. What's this thing? That's 10 microfarads at 65 volts. Well, you know what? I know that we're going to be taking these out. These capacitors are Callins, C-A-L-L-I-N-S, and these little guys are Temples. Okay, I've never heard of either one of them. There, look at that transistor. Something you don't see in today's world. Big old giant long tall case with the leads again coming down, just sticking out of the bottom of the board and wrapped over to where they go. Wow, this is neat. Yeah, here's an input transformer for the mic input. They both have them. If you're in this one, if you're in B, then it has a mic transformer too. These little guys nowadays are quite expensive. We don't actually use transformers anymore. And we got some sort of a VR here for adjusting. I haven't looked up what it is. Alright, so like I said, this thing actually still works on channel A. It does not work on B2 or B1, whichever one it is that's it would be channel A2. That input does not work. The channel 1 input for mic input does work, I believe. So that's what we got to fix. First of all, though, let's see. Let's take out one of these caps just for fun. Now remember, this thing was built in 1969. Widen this out a little bit. So let's take out one of these guys. Oh, wow. By today's standards, working on this is like working on an elephant. So big. Everything is so big. Alright, so before we take this out, let's make sure. Okay, nothing is marked. And so we're going to mark this. There, plus. Alright, let's take this guy out. Get out the little magic box. My other little magic box died on me. I don't know why. Excuse me. Like I said, I'm still a little bit on the sick side. My other little magic box died on me. This guy here just quit working. But I got this old original version, which it works. Alright. Put it on. This one you have to do leads 1 and 3 to find out what the ESR is. Alright. The other one you can, it doesn't matter. Alright, let's put it there. And capacitor. 84.38 microfarads with an ESR of 0.72. A little bit high, if you can see there. 50 microfarads at 25 volts, and this thing's measuring 84. That's a bit on the high side. Let's get another one out and see what it says. Alright. And this one, the plus is over here. Okay. These little fine-tip felt points are really handy. However, they dry out very quickly, so be careful with them. Okay. So, one nice thing about this old one is that reading there will stay up there for a long time, so you don't have to catch it before it goes away. But the other thing about this is that you have to hit the button every time. Alright, so this one says 80 microfarads with an ESR 0.79. So, I guess... I guess we're going to be replacing those. I want to bring this thing back to life here. Well, back to real life so that it's usable. Let's check one of the 10s. What are they? 10 microfarads at 65 degrees C. There's another difference for you. Alright. And this one's marked both sides. That's cute. Okay. Yep. So this side is plus. Okay, and let's measure this one. By the way, the board and everything that's in here is pretty much identical to the one that's in the other one. Just the programming is completely changed. So, all right, here we go, testing this one. Uh-oh. Oh. Okay, so 38 microfarads and an ESR of 2.7 on 10. Well, the 2.7 might be okay, but the 38 microfarads instead of 10 microfarads sure ain't going to get it. Look at this guy here. The 10 microfarads, 35 volts. 65 degrees C. Yeah. Okay. I do want to write down on here though. I want this to be 10. And this to be 50. And this is 50. Okay. Alright, well, with just a selection of these things, let's, I'm pretty sure they're all way out of tolerance. So what are we talking about? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13. So we got 13 50 microfarads and 1, 2, 3, 4, 1, 2, 3, 4 because of the one I got over there, and I got 4 10 microfarads. Okay. Wonder if I have that 1350 microfarads. Guess what, folks? It ain't going to be 50, that's for sure. It's going to be 47. 47 at 50. I don't think I do. No, I got 1, 2, 3, 4. Plus a bunch at 100. And some at 100. So new, I don't have 47. I got, well, I don't actually have 10s either. So I'm going to have to order some parts for this. Okay. Well, that answers that question. We're not getting this thing done today, because I don't have the parts for it. So what we got to do, we got to see 47 microfarads at 25 volts. Well, wait a minute, 25 volts. I might have that. I thought it was 50 volts. It's 10 at 50. 47 at 25. I got a bunch of little ones. There's 47 at 25. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I could put these guys, 11, 12, 13, so I can put those guys in there. Alright, so I do have enough of those. And I got 10. I only actually need 3 of those. 10 at 50. These are all 105s. Let's see. What's this one? Come here. Okay. That's 35 volts. 10 at 16. No, I still don't have 10 at 50s. Well, there's a 10 at 50. Yeah. I don't have any 10 at 50s. I got 16s and 35. So I'm still going to have to buy some caps for this. Yeah. Well, darn it. Well, alright. Of course, one of the problems here is the lead spacing and size. If you look at it, we don't want to really make this thing up so it's terrible looking inside either, because what I got here is, these are my, well, this is a cheapie, I think. Yeah, Bo-Yang, oh whatever. I'll get some good ones. But that is a 47 at 25 volts, and this is a 50. So if we look at the lead spacing here, it ain't going to be pretty. If I put this in the board down here, well, I guess that's not terrible. I don't think I'm ever going to get 47 27 to 25 with the lead spacing there. I think I just have to live with this. Alright, well, so much for today. So I need 13 of these guys and 1, 2, 3 10s. And also I'm going to need some capacitors or some transistors. Let's find out what these transistors are. Here's the schematic. So Q1, 2, 3, 4, 5, and 6, they're all there. Alright, where's the parts list? Parts list, okay. And the parts list says Q1, 2, 3, 4, and 5 are 2N2614s, 2N217s, 2N647s, and 2N2613. So, what are those? Let's see. For the most part, they're 2N2614. Let's see, 2N2614, and that would be PNP germaniums. Yep. And it says, well, I'm on Radio Museum. Radio Museum, by the way, is a pretty good source for some information on some of this old stuff. It's a PNP germanium alloy transistor intended as an RF amplifier. And it says 2N139. Let's pull one of these off of here, which is these go over the top and down through the hole. Up on the other side. That's just weird. Alright, so these guys have a little point to them someplace. No. Boy, old day stuff is interesting. Let's see if I can mark this somehow. Okay, so this... Okay, so... Let's remember... This one went in... It does have... It's a little flatter on one side here, and they form a triangle in this direction, and this back leg, presumably maybe the base, I don't know, goes back here on this back section. So let's find out what these are. Do one here, two, move away, thank you. Two there, and three there. So I got 1, 2, and 3 going across it. Let's see what it says. Yeah. I think I may have found one of the bad ones. This says that this is a diode. Let's do this again. Ah, there we go. Bad connection. So it is a PNP, and it's CBE. So, Yes, so CBE. So the base, the yellow one, beta of 10? Wow, okay. So it goes CBE. So this transistor is okay. We'll kind of put that back in because it's not marked. Yes, you can go through the manual and figure out what leg is what. However, it's easier if you just remember how you took it out to begin with. Okay, so it goes back, okay. Back in there like that. And that goes like that. And then these guys fold over. Hope you can see this. Let's see if we... This is how this old junk worked. Okay, so you take it, you fold this over, and you poke it back down in the hole, leaving a little on the top. Oh, darn it. I don't know where this other one went. It went right there. This is going to hurt. Yeah, it did. It does. Alright, let's put this one back on here. Okay. Are you up to speed yet here? There it is. Still got the coughs. Okay. And the emitter. I guess it's emitter. Well, this is tricky. Oh, excuse me. Alright. So that's back in there. Well, she looks like I'm going to have to order some parts. What is that little guy? There's a couple of those transistors. Well, let's see. Let's take a look at the schematic here and see what we got. It ain't much of a schematic. It's kind of cute. So, according to the schematic, what we're looking at, well, first of all, we got to go to the board and look at it. So this is 2A and 2B. Alright, so mic 2A all goes through there for that switch. And it comes in all of these things. Yeah, those are all grounded. So, so it comes in there into 2. And according to my schematic, two is right there. So we're looking at Q3 and Q4. Alright, so now we go back to the layout. And Q4, Q3. Alright, so this is showing it from the bottom. Yeah, from the bottom. And this transistor here, let's see, that is 6 right there, and we come down these two, and okay, so this is going to be Q3, no, this is Q4. Since that thing is just hanging out there for me to get to, let's see if I can actually test it in circuit. So this testing in circuit thing is usually a nope, but we'll give it a shot. It says PNP diode, EBC. Okay, well, I'm willing to bet that that's right. I mean, at least it showed it as a transistor. So that would be Q4. If we do Q3, okay, well, so welcome back, and I've replaced all the capacitors. Take a look in here. I sort of put it back together because it's so ungainly when it's taken apart, but take a look in here and you can see all the capacitors have been replaced down in here and all around. It's looking pretty good. I've got one thing I need to replace here when I can find one. Right now it's it'll lock the connector in. The little release tab that you have back here on the back for releasing the mic cable is broken on the A channel. I gotta get a new one of these, but I'll find one of those someplace. And basically all I did was I replaced all the caps, cleaned all the switches, cleaned the knobs, and cleaned the surface of it, and pretty much got it back to looking okay. So, tell you what, let's give it a shot. I'm going to plug in the power cord here, turn on the isolation transformer, and we'll give it a check. First thing we want to do is do the battery check, and as you can see, the meter goes right up to where it's supposed to go to, right up there. There's some grunge on here I can't get off of this, but it sure looks a lot better than it did. We'll put it on VU and plug in the microphone. I got a little old, I don't know what is this, limited edition ST95 MK2 Audio Technica, and we'll plug her in here and get something to make some sound here. I gotta make up a plug that'll go back here in this. We'll just hook it up across the balanced outputs here, and really need to make some sort of a balanced to go into my speaker. Alright, so we'll turn the master up. Well, first what you can do, This has an oscillator, and if we turn up the oscillator here, I don't want to turn it up too far. There, I don't know if you can hear that or not. That cutting out is because of my clip leads. No, it's not. It's because of this. Pot's still a little bit dirty. Gonna have to clean that up a little bit. But there's the oscillator. You'd send down the line and tell them that that's what you want for 0 level. And they down at the other end, they could go, okay, got it. And then you take the microphone. This is one of those silly mics. No real radio station would have a microphone with an on-off switch, because nobody would remember to turn the on-off switch on. So we'll turn that up and we'll talk into it. Alright, there we go. Look at that. Perfect. Just exactly what I expect to see. And it's about a third of the way up. That's about where it's supposed to be. Great. 1, 2, 3, 4. Okay, the noise you're hearing over here is coming from my little cheap speaker I stole out of a television. So we got channel 2A is working, or well, channel A is working, channel 1 over here. Let's give it a shot on 2, which means I have to get in here with a little screwdriver and release this, because it won't let go unless I do. There we go. That's what I mean. I need a new plug for that, new jack, or no, plug. Well, let's put her in 2A here and see if we get anything out of this. That would be 2B. Alright, there we go. 2B. We got audio coming out of it. That's great. That's what it's supposed to do. Let's see, what else? Let's see, 2A. How can I get some audio into this? Well, let's see. 2A would be the line input. That crackling is my speaker. Let's see. So channel 2A would be there. And I need to give that some audio. What have I got? Audio. Well, I guess turn this guy on over here. And a cable of some sort. Don't really have one of those. I know what I can do. We'll take it out of this, my generator, into here, and good old-fashioned clip leads. Too high. Alright, we'll feed it a little bit from here. There we go. Channel A. 2A, which is the line input. It works also. Beautiful. Great. Alright, so basically what we got here is a working Sparta RA-5. I need to make up some better cables. This is ridiculous. Okay, so now all I gotta do is put it back together and I guess put it back up on the shelf. as a just a thing, because it's kind of neat looking. There we go. A little more cleaning to do on the sides and stuff, but it works. I'm going to clean that pot a little more too. Alright, well, another piece of old radio gear brought back to life. I'll figure out something to do with it. I did check the headphones. The headphones do work. This takes, it doesn't take the regular headphones we use today, the low impedance. It takes a high impedance headphones, like 150 or above, so that we, like they had in the old days, but 150 ohms or above. So anyway, there we go. So thanks for watching. If you liked the video, give it a thumbs up, and we'll see you next time.